All right, so today we're going to be taking a deep dive into how Fastmail manages its hardware.
Mm,
And I think this will be super interesting for software engineers.
yeah.
We're going to kind of get into like the nuts and bolts of the choices that they made,
Yeah.
um, you know, how that impacts the performance, the reliability, all the things that we as software engineers,
Right.
think about and care about.
For sure.
And one of the really fascinating things about Fastmail is they actually use their own hardware.
Yeah.
They don't rely solely on cloud services.
Right.
And what's even more interesting about that is it's actually led to some pretty significant cost savings for them.
It has. Yeah.
And their hardware lasts a lot longer than you might expect.
Yeah. Their approach is really unique, and it kind of goes against the grain of what a lot of companies are doing these days.
Yeah.
Everybody's like cloud, cloud, cloud. But Fastmail has this long-term perspective, and they've been managing their own hardware for over 2 decades.
Yeah. Well,
So they really understand their usage patterns.
yeah,
They know what works for them and what doesn't.
that's amazing. So, how has their hardware kind of evolved over time? I mean, I'm imagining things were pretty different back in the early 2000s.
Oh, for sure. Back then, they were using a combination of spinning rust drives.
Ah, the good old days.
Yeah, those traditional hard disk drives. And they were using Arika RAID controllers.
Read controllers, those are the things that protect your data if a hard drive fails, right?
Exactly. It's all about redundancy and making sure you don't lose precious data.
Gotcha.
And they had this really clever system in place. They used faster SAS drives in a RAID 1 configuration for their hot metadata.
Okay, now you're talking acronyms. What exactly is hot metadata?
It's basically the information about your emails.
Ah, okay.
Think of it as the sender, the recipient, the subject, the date, all that stuff that describes the email itself.
So not the content of the email.
Not the actual message body, no. Just the stuff that helps the email system manage and deliver the messages. And since this metadata is accessed all the time, they needed it to be stored on faster drives for optimal performance.
Okay, that makes sense. So where did they store the actual email content then? The big chunks of data.
For that, they used slower set of drives in a RAID 6 configuration.
So they had different types of drives for different types of data.
Exactly. It's all about optimizing for performance and cost effectiveness. SATA drives are generally cheaper and offer more storage capacity, but they're not as fast as SAS drives.
Ah, so they used the faster drives for the data that needed to be accessed quickly, and the slower drives for the less frequently accessed stuff. Clever.
Yeah, and RAID 6 can tolerate the failure of 2 drives, which was important for those large email blobs.
So double the protection for the important stuff.
Exactly. They didn't want to take any chances with their users' emails. And to take things even further, they even had an archiving process that moved older email data from the faster SAS drives to those slower SATA drives.
So they were constantly shuffling data around to keep things running smoothly.
Yeah, it was all automated, of course, and they did it during periods of low server activity.
Smart. So they were squeezing every bit of performance out of their system.
Okay.
But I'm guessing they eventually made some significant upgrades as technology evolved, right?
Oh yeah, they're not ones to rest on their laurels. A few years ago, they made a big leap forward by transitioning to a pure NVMe SSD-based system.
Ooh, NVM. That's like the super fast lane of SSDs, right?
Exactly. NVMe stands for Non-Volatile Memory Express, and it's a much faster interface for SSDs compared to SATA.
I'm guessing that resulted in a pretty massive speed boost.
It was incredible. Their performance and density just skyrocketed.
Density meaning they could pack more storage into the same amount of space.
You got it. SSDs are physically much smaller than hard drives, so you can fit a lot more of them in the same server rack.
So what did their new hardware look like?
They went with a 2U AMD platform,
Okay.
packed full of those super fast NVMe SSDs. They were able to achieve much higher IOPS, which stands for Input-Output Operations per Second.
More acronyms, but I'm following you.
Basically, it means they could read and write data way faster than before.
Gotcha. Now, I bet that transition wasn't all smooth sailing, right? I mean, NVMe technology was still relatively new at the time.
You're right, there were definitely some challenges. One of the biggest hurdles was finding the right NVM RAID controllers.
Ah, right. Because you still need that redundancy, even with super fast SSDs.
Absolutely. You can't skimp on data protection no matter how fancy your drives are. And at the time, the options for NVMe RAID controllers were pretty limited.
What do you mean limited? Like not many companies were making them?
Yeah, there weren't many good options available. The ones that were out there were either crazy expensive or didn't meet their performance needs.
So they were stuck between a rock and a hard drive, so to speak.
They even considered ditching RAID altogether and using software-based replication for redundancy.
Wow, really?
But that would add a whole lot of complexity to their setup, and complexity is the enemy of reliability.
For sure. So what did they end up doing? How did they solve this NVMe RAID controller problem?
Well, they end up turning to a really powerful file system called ZFS.
ZFS, huh?
Mhm.
Okay. I've heard of it, but don't know much about it.
ZFS is known for its rock-solid data integrity features and advanced capabilities.
Sounds impressive.
And it turned out to be a total game changer for them. But choosing ZFS wasn't a simple decision.
Oh, God.
They had some concerns initially about how ZFS's copy-on-write behavior would play with their Cyrus email database.
Okay, copy on write. Break that down for us software engineers out there. How does it work, and why were they concerned?
So with copy-on-write, when you change a file, ZFS doesn't overwrite the original data right away.
Interesting.
It actually makes a copy of the modified blocks
Okay.
and then updates its internal pointers to point to this new copy.
So the original data stays untouched.
Exactly. It's a really clever way to ensure data integrity, and it allows for some cool features like snapshots and rollbacks.
That's pretty slick.
Mm-hmm.
So what was the issue with Cyrus and ZFS's copy on write?
Well, Cyrus, which is their email server software, uses a database structure that's directly mapped to files on disk.
Mm-hmm.
So any changes to the database mean modifications to those files. And with ZFS's copy on write, every little email modification, every new message, every change could lead to new data blocks being created.
Ah, so they were worried about performance hits. Like all that copying and pointing could slow things down, especially
Right.
with a ton of email activity.
They were concerned about the overhead.
So did those concerns turn out to be valid? How did ZFS actually perform in the end?
Honestly, it performed way better than they expected.
Really?
Yeah, it turned out that their fears about copy on write dragging things down were mostly unfounded.
Wow, that's a nice surprise. So ZFS really lived up to the hype.
Yeah.
What were some of the other benefits they saw from using it?
Well, one of the biggest wins was ZFS compression.
Okay, compression. That's always good for saving space.
They enabled transparent Z-standard compression, also known as ZSD,
Okay.
and this resulted in a 40% reduction in storage space.
40%.
That's huge.
That's massive. Did they have to spend a lot of time tweaking and tuning ZFS to get those kinds of compression ratios?
They did do some analysis. They were very thorough.
Yeah,
They took a sample of 1 million emails.
1 million emails.
Yeah, they wanted a good representative sample, and then they ran tests with different record sizes and compression levels.
So they were trying to find the sweet spot between maximum compression and the CPU overhead.
You got it. You don't want to save storage space at the cost of performance.
Right.
They had to find the balance.
So what did their analysis reveal? Did they find some magic combination of settings?
Interestingly enough, their analysis showed that the default settings actually work best.
The defaults.
Yep, 128K record size and ZDT3 compression.
Huh. Sometimes the defaults are the defaults for a reason, right?
It's like they were the Goldilocks settings, just right.
They hit the jackpot. But did they explore other ZFS features besides compression? It's got a lot of bells and whistles, right?
It does. They were also big fans of ZFS encryption, which, by the way, is built right into the file system.
That's convenient.
Made their security setup way simpler compared to using something like LUKS.
UKF.
Yeah, the Linux Unified Key setup.
Right. Keeping things simple is always a good thing when it comes to security. So they liked ZFS for email servers, but did they use it anywhere else in their infrastructure?
Oh, they went all in on the CFS, not just email servers, but their databases, logs, even their backup servers. It became their go-to for large-scale data storage.
Wow, they really embraced it.
Yeah.
Okay, so they've got this powerful storage system. Reliable, too.
Yep.
But there's always that lingering question with SSDs, isn't there? Longevity. How long will these drives actually last under heavy use, especially in an environment like Fastmail's?
Yeah, that's a fair question, and it's one that Fastmail took very seriously. They wanted to see real-world data on SSD wear and tear, and after running their ZFS-based system for a few years, they found that the wear rates on their SSDs were actually really low.
That's a relief.
Yeah.
So they're not anticipating having to swap these drives out anytime soon, just because of wear and tear, I mean.
Not really. In fact, they expect to replace drives due to capacity upgrades
Capacity of
or new formats
Remember.
long before they hit their write limits.
So as storage technology marches on,
Exactly.
they'll upgrade to those new, bigger, better drives.
Probably before their current ones wear out.
Makes sense. Good news for their budget, too. And speaking of budget, I know all this storage doesn't come cheap. They needed to upgrade their backup solution at some point, and that's where things got really interesting, I think, from a decision-making standpoint.
It was a really fascinating process. It shows how much thought Fastmail puts into their infrastructure choices. They basically had three options on the table:
Okay.
cloud storage, upgrading the hard drives in their existing server,
Okay.
or investing in new hardware with SSDs.
So the classic build versus buy scenario.
You got it. Cloud storage is all about that pay-as-you-go flexibility, but owning your own hardware gives you a lot more control.
Yeah. Let's break down each option, starting with cloud storage. What were the pros and cons that they were weighing?
Well, the biggest attraction of cloud storage is that you basically have unlimited storage.
Right.
You can scale up as much as you need without worrying about physical limitations.
The cloud is limitless, supposedly.
And if you use an S3 compatible API,
S3, that's Amazon's simple storage service, right?
yep, exactly.
For those who don't know.
If you use that, you theoretically have the flexibility to switch between different cloud providers.
Oh, yeah. So you're not locked in. That's
Yeah.
a good selling point. No hardware to manage, just pay for what you use.
Right. It's a very attractive model for a lot of companies.
It's tempting, for sure.
But there are some downsides to consider.
Of course, there always are.
First, the implementation cost. Switching their existing backup system to an object-based API for cloud storage,
Oh, yeah.
that could be significant. They'd have to adapt their software to talk to the cloud provider's API.
And that could involve some heavy lifting, right?
Yeah.
Rewriting a good chunk of their backup system.
Possibly, yeah.
Okay, so there's a development cost to consider. And what about the ongoing costs of cloud storage? I imagine those can add up pretty quickly, especially with a ton of data.
Yeah, you're essentially renting that storage space.
Right.
So you have a recurring monthly expense.
Right.
That's just going to keep growing as you store more data. And then there's the uncertainty. Will prices stay the same, go up, go down? Who knows?
Yeah, that unpredictability would make budgeting a nightmare.
Exactly, especially for a company like Fastmail that's all about optimizing costs. And don't forget about bandwidth costs.
Oh, yeah, you mentioned those earlier. How do those fit into the picture?
Well, depending on the provider and their pricing model, moving data in and out of the cloud can get pretty expensive.
Yeah, I can imagine.
Like, if you have to retrieve a ton of data from the cloud for a restore, that could result in some surprise charges.
Ouch.
And then there's the performance aspect.
Right. How quickly can you actually get your data back from the cloud?
Exactly. It can be slower and less predictable than accessing data on your own network,
Which could be a big problem for backups.
especially if you need to restore data quickly in an emergency.
Yeah, that makes sense. Okay, so cloud storage has its pluses, but it also has its fair share of challenges and uncertainties. What about option number 2? Upgrading the hard drives in their existing servers. Was that a viable option for them?
It was definitely the cheapest option up front. They were looking at Seagate Exos 24 drives.
Those are pretty massive, aren't they?
They are. They hold a whopping 24 terabytes each.
Wow.
By upgrading their servers with these drives, they could triple their storage capacity. Each drive cost about $500.
So upgrading a single server would set them back, what, $6,000?
Yeah, something like that. It sounds pretty good compared to the potential cost of cloud storage.
It does, but I'm guessing there were some caveats.
There were a few big unknowns with this approach. First, they weren't totally sure their existing hardware could handle those massive drives.
Right. Not all hardware is created equal,
Compatibility is always a concern.
especially when you're mixing older equipment with newer drives.
Exactly. And even if the hardware played nice, rebuilding a RAID array with those huge drives would take ages.
Yeah, RAID rebuild times can be brutal. I've heard stories of them taking days or even weeks for large drives.
It's not fun. And that downtime could impact their backups and restores.
Right, because the system's not fully operational during a rebuild.
And on top of that, there were performance concerns.
Even with the increased capacity, hard drives are still hard drives.
Right. They were worried the read and write speeds just wouldn't be enough to keep up with their backup needs.
So upgrading the hard drives was tempting from a cost perspective, but it came with some big risks and potential performance headaches.
Yeah, it was a gamble. So that brings us to option 3. New hardware with SSDs.
Okay, so they're thinking about replicating what they did with their email servers.
Yep, they were looking at a new 2U server that could hold 24 of those high-capacity 61 terabyte SSDs.
Hold on, 61 terabytes per SSD. That's insane.
And they'd configure them in a RAIDs 2 setup.
RAIDs 2, that sounds intense. Is that like RAID on steroids?
It's a ZFS RAID configuration.
Right, they love ZFS.
It provides double parity, meaning it can tolerate 2 drive failures without losing data.
So even more robust than RAID 6.
Similar concept, but with the added benefits of ZFS, like data integrity checks and self-healing.
So ZFS is like the superhero of file systems.
It's pretty amazing.
But those 61 terabyte SSDs, I can only imagine the price tag on those.
Yeah, this setup was definitely the most expensive up front.
I bet.
Each of those 61 terabyte SSDs cost about $7,000 at the time.
$7,000 per drive.
So the drives alone were $168,000.
Oof. And then there's the server itself.
Add another $20,000 for that.
So we're at almost 190 grand for the whole package.
Yeah, it was a serious investment, but they were thinking long-term.
Right, and spread out over several years, it might actually be a bargain compared to cloud storage at those rates we discussed earlier.
Exactly. Plus, you get all the other advantages of owning your hardware.
No recurring monthly fees.
Yeah.
You control the whole shebang.
Exactly. But there were some downsides too, of course.
I figured there had to be.
The upfront cost was obviously a big one.
$190,000 is nothing to sneeze at.
They had to weigh that against the potential long-term savings.
Right. Any other concerns?
Well, they knew they'd eventually need to plan for capacity upgrades.
Even with those monster drives,
Their data storage needs just keep growing.
the data never sleeps.
So while this hardware would give them a huge boost, it wasn't a forever solution.
I see. They had to factor in future expansion. So, tough decision, lots of factors to consider. What did they end up choosing? Did they go with the new hardware, the cloud, or the hard drive upgrade?
They decided to go with the new hardware, the SSDs.
They doubled down on their own infrastructure. What were the key factors that swayed them?
Well, a few things really tipped the scales. First, they had that hands-on experience with the 2U, AMD, NVMe platform and ZFS from their email server upgrade.
So they knew what they were getting into.
Yeah,
Reduce the risk.
exactly. And second, they were really sold on the reliability and performance benefits of SSDs.
Yeah.
Especially for something as demanding as backups.
Hard to argue with speed and durability.
And those massive hard drives, as tempting as they were from a cost perspective, just presented too many unknowns.
So it was performance, reliability, peace of mind.
And don't forget about the space and power savings.
Ah, right. SSDs are much more energy efficient.
Consolidating their storage needs onto a single server with SSDs
Right.
would free up space in their data center.
And reduce their energy bill?
Win-win.
Definitely. Did the familiarity with their existing backup systems also play a role?
Oh, for sure. They could reuse their systems and code, which meant less development work.
That's always a good thing.
Always a plus.
Less work for the engineers. Plus, knowing the upfront cost and having a good idea of the hardware's lifespan
Yeah.
makes it a lot easier to plan for the future, right?
Exactly. They had solid reasons to believe this hardware would last them for years.
So how did this bold bet on SSDs turn out? Did it meet their expectations?
It was a home run.
Awesome.
They achieved those crazy fast write speeds, 5 gigabytes per second during backups, even with ZFS compression running.
That's incredible. Sounds like Fastmail made a smart move. They did their research, and it paid off.
They really did. They understood their needs, they planned for the long haul, and they had the technical chops to pull it off.
A great example for other software engineers out there.
Yeah,
Sometimes owning your hardware can be the way to go,
absolutely.
especially when you know what you need and you're thinking long term.
Couldn't agree more. But it's important to remember it's not the right solution for everyone. You have to look at your own requirements and constraints.
Right? There's no one-size-fits-all in the world of infrastructure. So what does Fastmail's story tell us about the bigger picture of hardware and infrastructure choices? What are the key takeaways for software engineers facing similar decisions?
Well, I think Fastmail shows us that there is no one right answer. Cloud services have their appeal.
Right.
Flexibility, scalability, you can get things running quickly.
Spin up resources on demand.
Yeah, but they come with those recurring costs,
Right.
which can be hard to predict.
And you're handing over some control.
Exactly. Owning your own hardware, like Fastmail did,
Yeah.
can be more cost-effective in the long run.
Especially if you've got those predictable scaling needs
Right.
and you really understand your workload.
But it does require a bigger investment up front,
Right.
and you need the expertise to manage all that hardware.
So it's a trade-off
It is.
that every software engineer, especially those involved in these infrastructure decisions, needs to think about carefully.
Absolutely. No easy answers.
Yeah.
So any parting thoughts on trends in hardware or storage that software engineers should be paying attention to? What's coming down the pipeline that might impact those future infrastructure decisions? The advancements in storage tech are really amazing.
They-
We're seeing huge increases in storage density and performance
Yeah.
with each new generation of SSDs.
It's crazy how much they can pack into those tiny drives these days.
NVM drives are becoming more affordable,
Good.
more accessible.
That's great news.
And new form factors are popping up, like E3S,
E3S.
which
okay.
promise even better density and efficiency.
So the future of storage is looking pretty bright.
Hmm.
What about the software side of things? Any developments in file systems or data management that have you excited?
Well, ZFS continues to impress.
It does, yeah.
It's so robust.
Yeah.
So many advanced features. It's copy-on-write architecture, data integrity guarantees, the built-in compression and encryption. It's just a really compelling choice for demanding workloads.
Yeah.
And we're seeing more interest in things like software-defined storage
Okay.
and disaggregated storage,
Mm-hmm.
which offer more flexibility,
Yeah.
more control over how storage resources are used.
Right. It's a really interesting area to keep an eye on,
It is.
especially for anyone working with large-scale storage systems. It seems like the lines between hardware and software are getting blurrier and blurrier,
Yeah, they are.
which is exciting. Gives us more options.
More options, more choices.
And it brings up a question for our listeners. As storage technology continues to evolve at this crazy pace, what does the future hold for data storage? Will we see a resurgence of on-premises infrastructure, or will the cloud just keep on dominating?
That's a great question. I don't think there's an easy answer.
Yeah.
It depends on so many things. Cost, performance, security, and the needs of businesses and individuals are always changing.
The needs are always changing.
Always. But it's definitely a conversation worth having.
It is.
The key takeaway is that there's no single right answer. It's all about understanding your specific needs,
Good.
looking at the options, and making informed decisions that align with your goals. And as always, it's crucial to stay informed about the latest tech advancements
Right.
so you can make the best choices for your situation.
Well said. Thank you so much for taking us on this deep dive into Fastmail's world of hardware and storage. It's been really fascinating, and I think our listeners have gotten some great insights that they can apply to their own work.
Oh, it's been my pleasure. And remember, the best way to stay ahead of the curve is to keep learning, keep experimenting, and keep pushing the boundaries.
Love that. Thanks for joining us on the deep dive. Until next time, keep exploring, keep questioning, and keep diving deep.
Yeah, it really did. They were super happy with it.
That's great to hear. So it sounds like ZFS really came through for them. What were some of the other benefits they saw from using it?
Well, one of the biggest wins was ZFS compression.
Okay, compression.
Yeah.
That's always good for saving space.
They enabled transparent Z-standard compression,
Standard.
yeah, also known as Z, and this resulted in a 40% reduction in storage space.
40%. That's massive.
Huge.
Do they have to spend like a ton of time tweaking and tuning ZFS to get those kind of compression ratios?
They did some analysis.
Yeah.
They wanted to be thorough, so they took a sample of 1 million emails.
1 million emails.
Yeah, and then ran tests with different record sizes and compression levels. See, ZFS lets you configure how it divides the data into blocks and how aggressively it compresses those blocks.
Okay.
So they wanted to find that sweet spot,
Mm.
where they could maximize compression without killing their CPU.
Yeah. You don't want to save storage space if it means your performance tanks.
Exactly. It's all about finding that balance.
So what did their analysis show? Did they find some secret sauce setting that just blew everything else out of the water?
It's funny you should say that because their analysis actually showed that the default settings worked best. Yeah, 128K record size and STD3 compression, those settings gave them really good compression without putting too much strain on the CPU.
Wow. Sometimes the defaults are the defaults for a reason.
Sometimes the simplest solution is the best one.
Exactly. But I'm curious, did they explore any other ZFS features besides compression? I mean, ZFS is known for being pretty feature-rich.
Oh, for sure. They also loved ZFS encryption, which is built right into the file system.
Convenient.
Yeah, it made their security setup way simpler compared to using something like LUKS,
LUKS.
the Linux Unified Key setup.
Right,
Yeah.
right. Keeping things simple is always a good philosophy, especially when it comes to security. So it sounds like they were pretty happy with ZFS for their email servers.
Yeah.
But did they use it anywhere else in their infrastructure?
Oh, yeah, they went all in on ZFS. They used it for their databases, their logs, even their backup servers.
Wow. So ZFS became their go-to solution for pretty much everything.
Yeah, they found something that worked and they stuck with it.
Makes sense. Okay, so they got this awesome storage system. It's powerful, it's reliable, but And there's always that question with SSDs. Isn't there longevity? How long will these drives actually last, especially in a demanding environment like Fastmail's?
That's a great question, and it's one Fastmail didn't take lightly. They
Yeah.
really wanted to see how SSDs would hold up in the real world,
Yeah.
so they kept track of everything.
Okay.
After running their ZFS-based system for a while, they found that the wear rates on the SSDs were surprisingly low.
That's good news.
Yeah, they were pleasantly surprised.
So they're not expecting to have to replace these drives anytime soon just because of wear and tear?
Nope. In fact, they expect to replace drives because of capacity upgrades.
Capacity upgrades.
Yeah, or, new formats coming out long before they hit their right limits.
So as storage technology continues to evolve,
Yeah,
they'll probably upgrade to those newer, shinier drives.
probably before the old ones wear out.
Good for the budget. And speaking of budget, I know all this storage doesn't come cheap. At some point, Fastmail needed to upgrade their backup solution. And that's where things got really interesting from a decision-making perspective.
Yeah. This is where we see how Fastmail really thinks things through. They had three main options.
Lay 'em on me.
Cloud storage,
Okay.
upgrading the hard drives in their existing servers,
Right.
or going all in on new hardware with SSDs.
The classic build versus buy dilemma.
Exactly. Cloud storage has that pay-as-you-go flexibility.
Yeah.
But owning your own hardware, well, it gives you control.
So let's break it down, starting with cloud storage. What were the pros and cons they were considering?
Well, the big appeal of cloud storage is that you basically have unlimited storage.
Sure, the cloud is infinite, or so they say.
And if you use an S3 compatible API, you theoretically have the flexibility to switch between different cloud providers.
So you're not locked in.
Exactly.
That's a big plus. No hardware to manage, just pay for what you use.
Right. It's a tempting model,
It is.
but there are downsides.
I bet there are.
First, you've got the implementation costs. Switching their existing backup system to an object-based API for cloud storage could be a big undertaking.
Right, they'd have to adapt their software.
Yeah, they'd have to rewrite a chunk of their backup system.
So development costs are a factor, and what about the ongoing costs of cloud storage? I imagine those can get pretty hefty, especially when you're talking about backing up a ton of data.
You're right. You're basically renting that storage space.
Yeah.
So you have this recurring monthly expense that's just going to keep going up as you store more data.
Right.
And there's always the question of, will prices stay the same, go up, go down? Nobody knows.
Yeah, that unpredictability would make budgeting a real pain.
Exactly, especially for a company like Fastmail that prides itself on cost optimization, and then there's the bandwidth costs.
Oh yeah, you mentioned those earlier. How do those play into the equation?
Moving data in and out of the cloud can get expensive depending on the provider and their pricing model.
So if you need to retrieve a ton of data from the cloud...
Say for a restore, you could be in for a nasty surprise.
Ouch. Yeah. So cloud storage has its allure, but it definitely has its downsides too.
Okay.
What about option 2? Upgrading the hard drives in their existing servers. Was that a realistic path for them?
It was definitely the most budget-friendly option upfront. They were looking at Seagate Exos 24 drives. Those are the 3.5-inch hard drives.
Okay.
With a whopping 24 terabytes of storage each.
Wow.
So if they upgraded their servers with these drives, they could triple their storage capacity.
Triple the capacity.
Each drive was about $500.
So upgrading a server would cost, what, $6,000?
Yeah, give or take, it sounds pretty good compared to the potential costs of cloud storage.
It does, but I'm sure there were some catches.
There are some big question marks. First off, they weren't sure if their existing hardware could handle those massive 24 terabyte drives.
Compatibility issues.
Especially with the RAID controllers.
Right. Mixing older equipment with newer drives is always a gamble.
Exactly. And even if the hardware was compatible, think about the RAID rebuild times.
Yeah, this can be brutal,
Yeah.
especially with huge drives.
We're talking days or even weeks, potentially.
Oof. That downtime would definitely impact their backups and restores.
For sure. And then there's the performance aspect.
Even with all that extra capacity, hard drives are still hard drives.
Right. They were worried the read and write speeds just wouldn't be enough.
Yeah. So upgrading the hard drives was appealing from a cost perspective, but there were definitely some risks involved.
Lots of potential headaches. So that brings us to option 3, new hardware with SSDs.
Okay, so they were considering replicating what they did with their email servers.
Yep, they were eyeing a new 2U server that could hold 24 of those high-capacity 61 terabyte SSDs configured in a RAIDs 2 setup.
Hold on, 61 terabytes per SSD. Are you serious?
It's mind-blowing, right?
That's a lot of storage. And what's RAIDs 2? Is that like RAID on steroids?
It's a ZFS RAID configuration.
Right, ZFS. They love ZFS.
It provides double parity, so it can handle 2 drive failures without losing data.
So even more protection than RAID 6.
Similar concept, but with the added goodness of ZFS, like data integrity checks and self-healing.
Sounds impressive. But those 61 terabyte SSDs, I can only imagine what those cost.
Yeah, this setup was definitely the most expensive up front. Each of those 61 terabyte SSDs was about $7,000 at the time.
$7,000 up high.
But the drives alone were $168,000.
And then you've got the server itself.
Add another $20,000 for that.
So we're talking almost $190,000 for the whole shebang.
Yeah, it was a big chunk of change.
But thinking long term, it might actually work out to be cheaper than a year of cloud storage at those rates we were talking about earlier.
Exactly. And you get all those other benefits of owning your own hardware.
No recurring monthly fees.
No vendor lock-in. You control the whole enchilada.
It's tempting, for sure. But I imagine there were some drawbacks to consider as well.
Of course, there always are. The most obvious one being the upfront cost.
$190,000 is a serious investment.
Yeah, they had to weigh that against the potential long-term savings.
Right. Were there any other concerns they were wrestling with?
Well, they knew that even with those massive drives, they would eventually need to plan for capacity upgrades.
Even with 61 terabytes per drive,
Data just keeps growing.
it never stops.
So it wasn't a permanent solution.
Right. They'd have to factor in future expansion. It sounds like they had a tough decision to make, lots of pros and cons to weigh. So which path did they ultimately choose? Did they go with the new hardware, the cloud, or the hard drive upgrade?
After much deliberation, they decided to go with option 3, the new hardware with SSDs.
So they doubled down on their own infrastructure instead of jumping on the cloud bandwagon. What were the key factors that sealed the deal for them?
A few things really tipped the scales first. They already had experience with that 2U AMD NVMe platform and ZFS from their email server upgrade.
So they had a trial run.
Exactly. They knew the technology, they were comfortable with it.
That familiarity definitely reduces the risk.
And second, they were really impressed with the reliability and performance of SSDs.
It's hard to argue with the speed and durability of SSDs.
Especially for a demanding workload like backups. Those massive 24 terabyte hard drives, as tempting as they were from a cost perspective, just presented too many unknowns.
Yeah, too many what ifs.
Exactly. They didn't want to deal with the uncertainties of those huge hard drives, the potential RAID rebuild nightmares, the performance bottlenecks. It was just too much of a gamble.
So they prioritized performance reliability and peace of mind.
And let's not forget about the space and power savings.
Right. SSDs are much more energy efficient.
They could consolidate their storage needs onto a single 2U server, with SSDs free up some valuable rack space in their data center.
And reduce their energy bill.
Win-win.
For sure. Did the fact that they were already familiar with their existing backup systems play a role in the decision too?
Absolutely. They could reuse their existing backup systems and code, which meant less development work for their team.
Always a good thing.
Plus, knowing the upfront costs and having a good sense of the hardware's lifespan made it easier to plan and budget for the future.
Yeah, it's all about that long-term thinking.
Yeah.
So how did this big bet on SSDs turn out? Did it live up to the hype?
Oh, it exceeded their expectations. They were able to hit those blazing fast write speeds, 5 gigabytes per second during backups, even with ZFS compression enabled.
5 gigabytes per second. That's incredible. It sounds like Fastmail made a really smart move. They did their homework and it paid off.
They really did. They understood their needs, they had a long-term vision, and they had the technical expertise to make it happen. It's a great example for other software engineers out there who are facing similar infrastructure decisions. Sometimes owning your own hardware can actually be the best option.
Especially when you know what you're doing and you're thinking long term.
Exactly. But it's not the right solution for everyone. You have to carefully evaluate your own needs and constraints.
Right. There's no one-size-fits-all solution in the world of infrastructure. So what does Fastmail's story tell us about the bigger picture of hardware and infrastructure choices? What are the key takeaways here for other software engineers who are grappling with similar decisions?
I think Fastmail's story really shows that there isn't one right answer when it comes to infrastructure. You know, cloud services, they have their appeal.
Right.
Flexibility, scalability. You can spin up resources really fast.
Right, on demand.
Without having to manage hardware.
Right.
But they come with those recurring costs.
Yeah.
And those can be unpredictable. And you are giving up some control.
Right. You're at the mercy of the cloud provider.
Owning your own hardware, like Fastmail did, It can be more cost-effective over the long term,
Yeah.
especially when you have predictable scaling needs
Hmm.
and a good grasp of your workload.
Right.
But it does require that bigger upfront investment
Yeah.
and the expertise to manage it all.
So it's a trade-off.
It is.
A trade-off that every software engineer, especially those involved in these infrastructure decisions, really needs to consider.
Absolutely.
So any parting thoughts on trends in hardware or storage that software engineers should be paying attention to? What's on the horizon that might influence these future infrastructure decisions?
You know, the advancements in storage tech are really something. We're seeing huge increases in storage density and performance.
Yeah, it's mind-blowing.
With each new generation of SSDs, NVMe drives are becoming more affordable, more accessible.
That's good news.
It is. And new form factors like E3S are emerging.
E3S, yeah.
They promise even better density and efficiency.
So the future of storage is looking pretty bright.
Yeah.
What about the software side? Any exciting developments in file systems or data management that you're keeping an eye on?
Well, ZFS continues to be impressive.
It does, yeah.
It's so robust.
Yeah.
It's got so many advanced features, the copy-on-write architecture, the data integrity guarantees, the built-in compression and encryption. It's a really strong contender for demanding workloads. And we're seeing a lot more interest in things like software-defined storage and disaggregated storage,
Okay, yeah.
which offer more flexibility and control over how you use your storage resources.
Right. So it's definitely a space to watch, especially for anyone working with large-scale storage systems. It seems like the lines between hardware and software are becoming more and more blurred, which is pretty exciting.
Yeah, definitely. More options.
More options, more choices. And that kind of leads us to a thought-provoking question for our listeners. As storage technology continues to evolve at this crazy pace, what does the future hold for data storage? Will we see on-premises infrastructure make a comeback, or will cloud solutions just continue to dominate?
It's a great question, and I don't think there's an easy answer.
Yeah.
It depends on a lot of things. Cost, performance, security, the needs of businesses and individuals. Those are always changing.
Always evolving.
Right. But it's definitely a conversation worth having.
It is.
I think the main takeaway here is that there's no single right answer. It's about understanding your needs, looking at your options, and making smart choices that align with your goals. And as always, staying informed about the latest advancements is crucial.
Well said. Thank you so much for taking us on this fascinating deep dive into Fastmail's hardware and storage decisions. It's been really eye-opening, and I think our listeners have gained some great insights.
It's been my pleasure. And remember, the best way to stay ahead is to keep learning, keep experimenting, keep pushing the boundaries.
Love that. Thanks for joining us on the deep dive. Until next time, keep exploring, keep questioning, and keep diving deep.